What I have been seeing lately, that people are using simple stuff where a text classification can be used. So now today we are going to do this. Let's connect your T4 machine and install this dependency, because we are going to build our own text classifier from scratch without needing to call any API endpoint. So text classification are where you are using a language model and trying it to make do certain classification, whether it is positive, negative, or any type of keyword classification. So this is what we are going to do here. Let's load the dataset. Let's take an example of Rotten Tomato dataset. It's a public open source dataset that we can use with the help of transformers load dataset function. Oops, I made a mistake here. Let's first install. Make sure do not forget to install it, and then import it from datasets, load datasets. Once it's done, let's run it. Once you execute this code, it's going to load the entire dataset for us in a very convenient way, where we will already get the data in the form of text, test, train, validation. So just let's see one of the entry of the dataset. See, you have a text and then you have a label. Now where the label 0 means it's a negative review and 1 means a positive review. So this labeling you already have. Perfect. This is what we want for supervised fine-tuning. You need data in this form. Alright, so let's begin. Just see, you have train, test, split, validation already prepared for you. Now let's create the pipeline as we have done in the first chapter. Let's also return all of the scores, and let's see if we are connected to the GPU. Perfect, we are. And let's execute this code. It's going to take some time. Meanwhile, I'll explain you what's happening, but you need to also specify the model path. So that I have done it again here, and this time hopefully will not have any error. Perfect, it's loading all of the models that we want, this safe tensor and all. Now what I am going to do is to write some helper function which is going us to use that pipeline, and then what we want to stream this text that we have into that text pipeline. So for that we'll use key dataset, and we are going to let's pass a smaller dataset for this tutorial. Test 1, let's collect the negative scores, the positive scores. And so reason why I'm using 0, 1, 2, because this model predicts 3. It also predicts the neutral one. So that's why since our data labeling is in the only 2 labels, it's better to use that way. So as you can see, the training is completed and we are able to see our predictions over here. Sorry if I said training, it's actually we are just doing the only the prediction for now. So this is an helper function which is going to generate the classification reports from Scikit-Learn. We are interested in knowing the F1 score and all of these things that we just got from the above. So let's pass the label. So also we'll pass our ypred that we just calculated above, and let me type it, ypred, and let's execute it. There you can see we have a good performance actually. So the model is quite good, given it has been trained on the Twitter dataset, but it also works for our Rotten Tomato dataset because it's transferable. So that's the important thing. Alright, so now what we are going to do is to try another model. Let's use sentence transformer, and let's do embedding based approach. So from sentence transformers, let's import sentence transformer. And then let's also bring our model, which is all MPNet base v2. It's actually quite good model when it comes to text embedding. So let's calculate the training and test embedding using model.encode, and then let's also show the progress bar. Same thing we do it for test as well. Perfect. So once this is done, let's also print the shape. I assume it's about 768. Now let's do one thing. Let's pass all of this through a logistic regression model, and let's train that classifier and see if we are able to improve what we have seen above through a vanilla model to a logistic regression model, prediction from there. So what we are doing, a classical machine learning on top of our embedding. And after that we are going to call the same helper function that we have made. Again, I have to just remove the s. Yep, yes, let's call it again, and we can see it's now it has better performance. And now let's run it. So what I am going to bring some of pre-written code over here. What it is doing, what I am trying to prepare is a zero-shot classification using labeled embedding. So let's use the data frame, and so what I am doing is appending label as column index 768 because we have the embedding 767, and then just group by with the mean and take an average, so that we'll have all of the samples, mean embedding and the sample itself. And after doing that, we will be able to calculate the cosine similarity without even training that model. And let's compare, if we don't train a model, what will be the performance of it. I believe it will be low, and then that what we are seeing. So let's now we are going to call that model dot encode on a negative or a positive review. Let's see its performance, and let's do one thing. Let's call the cosine similarity. We have test embedding and its label embedding. Let's collect the verb predictions. Again the same mistake. Let's move the s. Now let me run it again, and then using flan t5, let's evaluate the performance. It's quite down, which is expected because we had trained a logistic regression model which performed quite well. So here's the summary. You should use your own model for such task. Thank you.